he's sitting now in Winnipeg. McManus, Braverson picked off. It's over now. Gerard
Interception!
Touchdown, Winnipeg.
Woo! And speaking about interception, that leads us into 6.8. Intercepts!
What does the football have to do with the math?
Well, just like the other team met the football to score a touchdown, whoop whoop, Winnipeg, intercepts in math talk about when the graph meets one of the axes.
Oh.
So, we have y-intercept when our graph meets with the y-axis. And in that case, the value of x when our graph meets the y-axis is 0. And we can see that if we're looking at this graph. This is where, oops, this is my x-axis. My y-axis occurs along this line. And the value of x at any single point on that vertical line is 0. So a y-intercept occurs when x is equal to 0. Key point. We also have an x-intercept, and that's where the relation or function meets the x-axis. And the value at the x-axis, the value of y at the x-axis is 0. So if we're looking at the x-axis here, that horizontal line, the value of y at any given point on that line is 0. So key things is that's not a highlighter. Is knowing that y-intercept occurs when x is equal to 0, and an x-intercept occurs when y is equal to 0.
On graphs themselves, for a y-axis, we can just look for where we touch the y-axis. For the x-intercept, we can look for where we touch the x-axis. So on this one, we touch the y-axis right there. The value of y over there is 2. So we can say that the y-intercept is just straight up y equals 2. That's the value of the intercept. We can also state the coordinates of the intercept, and those coordinates have to be in an xy form. We know that y is 2. What else do we know when we're talking about a y-intercept? Well, per that definition, the x value has to be 0. So for this point here, I went to erase that, totes. That point is the point 0, 2. So if you're asked for the coordinates of the intercept, you say it this way. Take a moment, see if you can get the intercept, or x-intercept. See if you can get it as a value, see if you can get it as coordinates. Whoop, time's up. Here I go. It happens right here. That's when x is equal to -3. And then as coordinates, we're talking about the point where x is -3 and y is 0. Because we haven't gone up or down at all, we're just sitting right on the axis.
All right, we could take a look and find the intercepts of the functions below. We're going to list them both as the value and as the coordinates. Now, after that example, you might just think, man, I could probably do this on my own. Well, why don't you give it a try? I believe we have 4 graphs here. See if you can do that. But I've assumed you did it. And we're going to move on here. So here we're going to do the x-intercept, and we're going to do the y-intercept. So I'll start with x first, because alphabetical. The point in which our functions hit or meet the x-axis occurs here. That is the point in time where x is equal to 1, 2, 3, 4. So we could say x is equal to 4. If we are indicating this as a coordinate, well, x would still be 4, and as per definition and as per what we could see on the graph, y would then be 0. So we had the coordinate point 4, 0. Our y-intercept occurs when we meet with our y-axis. And here we have y being equal to -2. And in a coordinate indication of this intercept, we know that y is -2 Well, what is x? As per the definition, but also as per the graph, we can see that x is equal to 0.
And this next one. The x-intercept happens when x is 3, right over there, and the coordinates of that point are 3, 0. The y-intercept happens when y is equal to 2, right there, and that's the point 0, 2.
All right, next one's here. Okay, so we're going to start with the x-intercept. So we're going to find a point on the graph in which the graph meets the x-axis. Well, there's a point. Whoa, but there's also another point. So we have two x-intercepts in this point, or in this case. So we can state them as a value. We could say, well, x is equal to -2 and 4. We could write that either as two statements, so we could say x is equal to -2 and x is equal to 4. Or we could indicate it with that comma, just for a little bit of simplicity's sake. We can also state this as coordinate points. Of course, we cannot combine those coordinates because the coordinates have specific 2 spots. So we could say the coordinate for my first x-intercept is -2, 0. And for the second x-intercept, we could say that's 4, 0. Whoa, 2 x-intercepts. How many y-intercepts? Well, considering we said that these examples were functions, we'll never actually have 2 y-intercepts for a function, because if we did, here's one, if we say had another one here, it would no longer pass the vertical line test, meaning it itself would not be a function. So since the example stated that, this kind of makes sense that we don't have more than one. So the value at that y-intercept, well, that's when y is equal to -4. And as our coordinate point, we can indicate that as 0, -4.
Hopefully you've tried this last one already. And in doing so, when you search for the x-intercept, you found nothing. We are never touching that axis. So there is no x-intercept. So sad.
Keep in mind that you cannot write x-intercept so x is equal to 0. Because 0 indicates the space where the x-intercept occurs. It doesn't indicate the number of x-intercepts we have. So it would be incorrect to write x equals 0, but it's totally fine to write none, does not exist, not applicable.
So this is where x is equal to 0 for an x-intercept. And that is not what we have going on here. Y-intercept happens right there. So that happens when y is equal to 4. So that's the point 0, 4.
All right, so we can determine our x and y intercepts graphically by just visualizing where they occur. But sometimes we're not given the graph. Sometimes we're given equations. And we can still figure out what those intercepts are. Remember that we can find both the x and y intercepts knowing that at the x-intercept, y is equal to 0. So what we could do is we can plug in 0 every time we see a y and determine that value of x to then give us that point that we could then express as a coordinate. And if we're trying to find the y-intercept, well, that occurs when x is equal to 0. So we can plug in 0 for x and solve for y. So we're going to do this for this first question here. So we're going to find the x-intercept. First, I always like to write at the top of my page when I'm doing this, x-intercept when y equals 0. Because it helps solidify that understanding that I'm looking for x when y is equal to 0. That's when the x-intercept occurs. So every time I see a y in the equation, I'm going to plug in 0. So I get 0 equals 2x plus 6. And now I'm going to solve for x. So -6 minus 6 minus 6 is equal to 2x divided by 2 divided by 2. X is equal to -3. So that is the value of x when my y is equal to 0. That's the value of x when I have my x-intercept. But the question does specifically ask for me to write that as a coordinate. So the coordinate of my x-intercept, well, I know the value of x is -3. Boop, boop. And my value of y, as always, will be 0. So this is my coordinate. So I have my x-intercept occurs at, oops, maybe I'll just move this guy over, scoot that out of the way, move it back so I'm not intruding on other space. But this is what I have. My x-intercept occurs at the point -3, 0. All right, we can also solve for the y-intercept. The y-intercept occurs when x is equal to 0. So at this point, I am going to plug in a 0 every single time I see an x in that equation, and I'm going to solve for y. So I get y is equal to 0 plus 6, so y is equal to 6. That is the value of y when I have my x-intercept. So again, I have to state this as coordinates. So my y-intercept occurs at the point 0, because that's the value of my x. Oops, sorry. And +6, so 0, 6. If you haven't paused and tried anything on your own yet, this would be a really fantastic time to do that for this next example. Same ideas, same steps, but now just a different equation.
Looking at this, we're going to get an x-intercept. When does that happen? That happens when y is equal to 0. So we've got 0 minus 4 equals 2/3 of x plus 3. And then we're going to solve this little bit by bit. What do I want to do? Well, let's see, this is just -4. I'm going to divide both sides by 2/3. So multiply by 3, divide by 2. So on the left, I've got -6. And then I've got x plus 3 on the right. Subtract 3 from both sides. Boom diada. So I can say that we have an x-intercept at the point -9, 0. Y-intercept, where does that happen? As far as I'm aware, that happens when x is 0. So we're about there. And solving for y there, y minus 4 is 2/3 times 3. So y minus 4 is just 2. And thus y is equal to 6. And we can say then we have a y-intercept at the point 0, 6. So we can also find intercepts of quadratic relations. That's exciting. And we can do that because we know how to solve quadratic equations by factoring. It will be a huge step for finding, well, for these ones, for finding the x-intercepts.
So notice that in these examples, it's asking us for the values of the intercept. It's not specifically asking for the coordinates. So we can state our answers as x is equal to blah, or y is equal to blah. So we are going to kick things off. We are going to look for the x-intercept first. That occurs when y is equal to 0. So plugging that in, we have 0 is equal to x squared minus x minus 6. Because this is quadratic, we have an exponent of 2 on our variable. The only way we know how to solve is by factoring. So we have to start by factoring this guy over here. I'm looking for factors of a times c, which is -6, that add to give me -1. So that's going to be -3 and +2. I can factor by decomp, but knowing that my a value is 1 here, I know that those factors that I find are actually just going to be easily inserted into my factored form. So I have x minus 3, x plus 2 as a factored form. Now, I need to solve for x. Well, because I have two things multiplying to give me 0, I could say, well, either the first one is 0 or the second one is 0, and I could solve for x in both of those cases. This one here would say x is equal to 3, and this one here would give me x is equal to negative 2. It looks like I'm going to have two x-intercepts. They're going to occur at the point 3, 0 and negative 2, 0. But again, the question just asked me to find the value of the intercept, not the coordinates of them. So I'm okay with leaving my answer here. I also have to find my y-intercept, and of course that occurs when x is equal to 0. So I'm going to find y, and I'm going to plug in 0 every time I see an x. So I have 0 squared, which is just 0 minus 6. So y is equal to minus 6. And again, because the question asked me specifically for the values, I am a-okay with leaving it as such.
So try these other ones, of course, and see if they match up with what we get here. I'll find my x-intercept. However you choose to factor, just make sure that you can factor this thing. I'm getting that's x plus 8 times x plus 2. So we break it to cases where one of those gives us the solution that x is negative 8, and one tells us that x is negative 2. So these ones have two x-intercepts. And that y-intercept, as always, is happening when x is 0. Oops, I wrote x here, but I should have written 0. So 10 times 0 plus 16. 0 plus 0 plus 16. And that is where that one is occurring.
All right. And again, if you haven't paused yet, now is the time to do so. We have two examples left. We're going to continue as such. So we have my x-intercept that occurs when my y is equal to 0. I'm going to plug in a 0 for y, and I'm going to solve for x. 3x squared plus 7x minus 20. The only way I know how to solve is by factoring. So let's get to it. I am looking... You know what? I'm going to do this one by decomp, because why the heck not? So I am looking for factors of a times c, which is negative 60, that add to positive 7. So I'm thinking, and I have, what do I have? 12 and 5? No, because I need to have negative 6. Oh, I could have positive 12 and negative 5. There we go. Whew, that works out. So I have 3x squared plus 12x minus 5x minus 20. Since I'm solving by decomp, I have this kind of little bit of extra work to do here, but that's a-okay. X plus 4, and I'm going to take up a minus 5 here, which gives me x plus 4. After factoring, I get x plus 4 and 3x minus 5. You could have also done this through logical reasoning. Either would have been fine. And of course, I have two possible cases. I have the case when x plus 4 is equal to 0 or 3x minus 5 is equal to 0, because those things multiplied together need to give me 0. Which means x has the value of negative 4 and x has the value of 5/3. So I have two x-intercepts in this case, and they occur at the points negative 4, 0 and 5/3, 0. I'm going to shrink this down just a smidge because I took more room than I wanted to. Beep, boop, bop. Ah! I said beep, boop, bop. Whew. So now I'm going to find my y-intercept. Again, that occurs when x is equal to 0. So I have y is equal to 3 times 0 squared plus 7 times 0 minus 20, which gives me 0 plus 0 minus 20, meaning y is going to be negative 20. The value of y at my y-intercept is negative 20, which occurs at the point 0, comma, negative 20.
And the last example is over here.
Woo!
We're going to have to find its x-intercept, and at some point, probably its y-intercept as well. So the x-intercept is when y is 0. And solving this one, I'm going to go factoring again, because I see that we've got a quadratic term. So we've got 2 times 9 minus x squared, which is 2 times 3 plus x times...
Ooh, the difference of squares. Nice.
Yeah, it's a fun one. So our options are, well, when 2 equals 0, which is never, or when 3 plus x is equal to 0, or when 3 minus x equals 0. And thus, x is, it's like I've never drawn a negative sign. There we go, negative 3, or x is positive 3. And you could write it this way as two distinct things, and don't forget that you could also write it as just x is plus or minus 3. So you could write it that way instead. And the y-intercept, as we've well established, occurs when x is equal to 0, which in this case just means we've got 18. Boom, the end. So there is some practice work on the next page for you to look at with your eyeballs.
Woo! Who doesn't love some good practice? And check it out. There's some answers at the bottom for you to double check that you're on the right track. Otherwise, that is it for 6.8. We have one more section until we're done. And we hope to see you soon for 6.9.
Woo! Adios, muchachos.